This is eHobbyist blog, a log of electronics hobbyist activities aimed at city dwellers who have limited space, limited money, and limited time. My name is Neil. Welcome. During this video, we will conclude installation of the power transistor sockets and associated feed-throughs. Now, I'm going to start by installing the solderless insulated feed-through connectors, and I'm doing this with about the smallest nut driver I can possibly find to exert pressure around the Teflon collar of these insulated feed-throughs, and then I finish it off by trying to exert some flat pressure against it with a screwdriver. Now, these things have to be force fit into the holes, but I can't overdo it or I might distort the connectors. And so I test each one of these connectors with a solid number 22 wire, and if I hadn't distorted them or bent them, that 22-inch wire should fit snugly into these solderless feed-throughs. And it does. Looks like everything is okay so far. Now I'm going to flip these and start installing transistor sockets. The transistor sockets I'm installing is using a number 6 screws, lock washer, and a nut. And we want to get these hand tight, or I do. But I don't want to over tighten them because these things are going to have to be removed probably a number of times in the future as this project progresses. Going to at least go through one round of cosmetic surgery on the front panel, subjecting it to numerous layers of paint, and I probably want to remove things like transistor sockets and not expose them to getting painted. So we'll keep these snug but removable. I wish I could move this fast in real time. I really like this speed up stuff. It was so torturous the first time around. And I can appreciate now how slowly I put these things together and how time consuming it is. Now I'm going to cut hookup wire to size. These are pre-measured pieces, cut just large enough to connect the transistor socket connectors to their corresponding feed-through lugs. Having cut all of the wires to size, I will next strip the wires. First one side, and then the other. Doing it this way I find it's more tedious, but less prone to error. If you're just doing one thing many times and then going on to a second thing many times, as opposed to trying to do it all at once on one piece of wire or one piece of anything. Now let's strip the second side. And this isn't accidental. I'm not improvising. The length of wires, how far I had to strip them, were determined ahead of time. It may not wind up being on camera because that too is tedious and I'm trying to avoid tedium. But it's not an accident. And this time I am using an automatic wire stripper. Now let's twist the end of the wires and I'm going to crimp them on one of the conductors using a not-so needle-nose pliers. Now crimp this in place, wrap it around the second conductor. Let's tighten up on that. And then wrap it around the lug of the corresponding feed-through connector. And try to crimp that. Now I'm applying a liquid flux, and thereafter I'm going to solder the wire to the feed-through lug. And next time I do this, which will be never, I should rev up the soldering iron to a higher temperature. Now I do notice the smoke, which is going in the wrong direction towards me. I didn't notice this as I was doing it. Apparently, somebody forgot to turn the fan on. I have a small fan that sits on the tabletop and sucks air away from the solder work and through a carbon filter. Now, these carbon filters are amazing. If you've ever had any kind of experience with having to get odors out of the air, the carbon filters are just astonishing in what they can accomplish, and they do indeed filter out smoke. It's not that the toxicity from the solder is from vapor, lead vapor. That probably is not enough to get you immediately. I'm sure anything in excess will kill you, but I think the true toxicity here is from the smoke generated by roasting flux. And the flux is caustic and has no business being in your lungs. So I will endeavor to remember the next time to turn the bleeping fan on. Doing this will allow me to plug in power transistors into these sockets and then make connections using solid hookup wire from the solderless feed-throughs to any part of the circuit being prototyped. There's a certain advantage to that, rather than having things laying around connected by alligator clips and what have you. There's just no getting around this. I mean, it's long, it's tedious, and it's repetitive, and the danger here is falling asleep and doing something stupid. But looking over this video, I don't see that anything truly stupid is being done, other than editing these videos down and releasing them to YouTube. I've wondered about the intelligence of doing that. But at least the videos are being stored by YouTube and not by me, but there's just 15-minute spurts of them. Now, where are we in the stream of things here? We're doing this by the numbers, brown meaning 1, red meaning 2, and orange meaning 3. Electrician's color code. I am not a professional electrical engineer. I don't know the difference between a dynamo and an alternator. But if somebody establishes a color code, I suppose I should at least endeavor to... Okay, now I can hear the fan going, just about the time I'm ready to finish up here. And here we are. Liquid flux on the last wire. And visual inspection. While I'm doing this, I'm visually inspecting it from the video, and there's nothing wrong with this stuff. It looks good. It looks good. There's not too many things that could go wrong with this. I'm sure if there were, I'd find it, but I can't see anything going wrong. And we appear to be done. We gotta clean the flux off. I want to see bright, silvery solder connections. There's a matter of aesthetics here. Now, let's test the continuity between the socket conductors and the corresponding feedthroughs. I don't know what's going on here. Okay, we've tested to make sure the continuity tester is working. But I don't hear any beeps. There is no continuity for any one of these things? This is not good. As a matter of fact, it's so not good, it's time to panic. Did I waste a whole lot of time installing transistor sockets that are defective? Let me just test the continuity of these soldered wires. They're all good. I mean, what can you say? You know, this is not high level. Okay, I see what the problem was, and now we're using very small probes to actually insert into the transistor sockets. What was happening is the leads, the test leads I was using, were too wide by just a little bit. And they felt like they were making contact with the transistor conductors, and they weren't. So now I've got the very small probes that can not only be inserted into the solderless feedthroughs, but can also be inserted all the way into the transistor sockets. And now I'm getting the beeps, and now I'm confirming proper continuity and no shorts. Okay, this thing had me going for a while. Didn't make sense. At that point in time, you just have to let your subconscious mind filter through the junk. Normally it does. In this video, we press-fit solderless feedthroughs, mounted the power transistor sockets, soldered hookup wire to the transistor socket leads and to the corresponding feedthroughs, tested the continuity of transistor socket leads with the feedthroughs. A problem with the digital multimeter test leads was encountered, identified, and corrected. In the next video, we will be installing BNC connectors. If you like this video and the idea of the channel, click on the YouTube thumbs up icon. If you want to be notified as to when the next video is available, click on the YouTube subscribe button. If you want to suggest future directions or topics, make corrections to published videos, or voice your opinion on related matters, then leave a YouTube comment. If you want to see supplementary material that cannot be easily presented in video form, such as high-res graphics, files in different formats, lists of references, go to the corresponding website. Until the next time, good day.